Okay. Hello. Welcome to the lesson 4 of the beginner course. I'm Erwin. I'm the tutor, and as always, I'll be talking about some things that I want to expand a little bit on the course, and maybe talk a bit on depth about the stuff that happened in the lesson. On this lesson, we saw mostly all about how to save data, access data, and load data using loaders, using the assets, and using the different ways to access the data. Background services, SQLite database, that is the default database that works on Android. We also saw the loaders and the special case of the intent service that is a background service that actually handles the background processing for us. Um, okay, so what's the important part about this lesson? We have to learn about data, handling data, saving data. Um, so I want to talk um, a little bit uh, about data and the different ways we can actually handle the data on Android. Of course, we already saw how to data. We saw the data, of course, as I said, the database, the providers, the loaders. But let's begin a little bit about why persistent data. Almost all applications will have to save data. So we have to know the ins and outs of the options we have available. Um, Database, preferences, and files. A database, as the default, uses SQLite with it's an SQL database that is pretty lightweight, and it's designed for mobile. Well, no, maybe not designed, but it's really useful for mobile because it's really lightweight and it's perfect for this kind of environments where the memory is limited. Shared preference is the class that we use to save simple data. Of course, you might have guessed from the name that shared preferences are used to store preferences. And this store persistent data. This means the data we store in a preference will stay even through the app closing or being killed by the operating system, and even through reboots. So we can store our data safely in this kind of classes. And finally, files are the same way, are they handled the same way as they are handled in Java. So there's really not much to talk about there, other than maybe some uses and some stuff. But if you know how to use a file in Java, you know how to use a file in Android. Now, a little bit about SQLite. For those that don't know how SQL works, it's a relational database, meaning that you can actually relate a table to another in the using of IDs and queries. Queries have this kind of format where you have the operation in you and the table that you're reading and the conditions. This can get quite a bit more complicated, but this is usually the most simple type of query that you can have. Select from a table where some ID equals a value. And tables are stored like this. They are by columns, and each column has its own header. The header is the identification, the ID where we'll query the data from, and this is how relational databases work. There are also non-relational databases. there's Firebase that has a lot of support for Android. We actually cover that in the next course, in the professional course. So be sure to read that. Firebase also has a lot of great perks and uses because you see it's a online database and we already have the API to connect to it. So and it's integrated with Android. So if you want to have a server type application, Firebase is a good option for that. But going back to SQLite. SQLite is a relational database. I already talked a bit about this, meaning it has tables, and we query those tables. We insert the data as rows. Like if on this example, if we wanted to insert a new row, we have to give it an ID, a name, and a grade. All right, pretty simple. So it's simple and lightweight. This means it's a lot lighter than an usual SQL database, and this because it's used mainly for mobile platforms. So SQLite has a lot of things that many others don't have that might be a little problematic depending on what kind of functionality you want, but it works really well for mobile. And it's our main way of storing data. So that's the things that we want to focus on. So in Android, each application has its own sandbox, right? Meaning they have their own context and their own databases. So there is no like way to get into the database of another application. Like you save your data in an SQLite database, and other application can't really access that database like we can. Like they can't query the database, or they can't update or delete stuff from the database. Of course, this I already mentioned, but there's a problem. It lacks many functions. Some of the things are pretty crucial when we want to implement a database. We have to make sure there isn't really no things that may be lacking here. That but because if you had a previous experience with an SQLite, SQL, sorry, application like MySQL or even Microsoft SQL Server, you know that there are some functions like users, like you can define access type by users, you can define functions and special protocols, methods that you can do on updates, on queries, and all that. But most importantly, security. SQLite doesn't have any sort of security or encryption. It's one of the things that you have to handle yourself if you want to actually use the database. So it's the most important thing to remember. You don't have to, you shouldn't store important data like credit card information, addresses, or stuff like that. It really shouldn't be stored on an SQLite database because it's stored as plain text. It doesn't have encryption, it doesn't have security. And while an application it runs on a sandbox and has its own database, you can still access that. It's not like it's unreachable. You only have to know how to access the application data, and you have total access to the application database. So it's not a good idea, unless you do some encryption on your part, but still it's not really the best option. Okay, so I talk about some perks, some problems with the database, but how do we access this database? We already saw in the lesson how this is done. They are it's done in two ways. First of all, is using the content provider. It's the main focus of the lessons app. Okay? Use a content provider, creating URI, and using that, you have the path to the data. Um, Using the methods from the content provider, you access the data and query the data, and you can use that. It's a, a good way to access the database without knowing much about the structures, because it's using methods, and you receive parameters like the query and the query and the parameters. Like an update query, you will receive the file, the row to be updated, and the new values. That is done by a content value, and that is just an object that stores data and handle and is used together with the content resolver to actually handle the data that is being passed through the content values. Okay, and the other way is querying the database. And this can be done by direct queries or raw queries, where you just write the query like the one I showed before. You just pass a string like update name from the student table, and that's how you can do it. But those things can be a little bit tricky, and it's really not a good idea to mess too much with that if you don't have some experience relational databases, especially with the delete operation. Is really the worst one to try and modify if you are not familiar with those. Um, Remember the where clause, like it select a row from a table where there's a condition. Well, delete also has that condition, and one of the worst errors that you can do when handling a database is actually skipping the condition on the delete in the delete option, because then it will just delete the whole table, and that's really, we don't want to do that. So this, these are the two ways that we saw: a content provider and a DAO. A content provider, it provides an abstraction to access the database, meaning it handles already all the functions that we expect from a database: reading, creating, updating, and deleting. It uses a control solver to share data. This is really the most important function of a content provider. And really, if you're not sharing data, there's really little reason to use a content provider, because that's its main advantage. So, of course, you can always use it to access your own data, but it's like it's really not its purpose. And then it can be used for apps or even to share data with widgets. Like you pass the data to a content provider, and then the widget will receive that in an app widget provider. Well, of course, see this in the next lesson, lesson 5. But the widget provider just is the one that handles the data being passed to the widget. So you can actually use a content provider to query the data and then send that data to the app widget provider. Uh, and the important part is that content providers, we already know, can share data with another application. And a content provider sharing its data, you might think it's really not, well, the application we saw and we learned in the lessons really don't showcase this function very well, because they are mostly self-contained, right? But an application like might want to share data, like it's doing some calculations or it's saving some images, some texts. It might want to share that with other applications because maybe other applications can also do some work on that data. Even we can, of course, think we have an application that is getting bigger and bigger with each and every update. So we might want to split the application if there are too many unrelated functions, like imagine a text processor and then an image one. We, we may not don't have need we may not have a need to have those two things together, but maybe they want to share some data like location or something to know where the user is taking the information from, or maybe something like an account or some credentials. We can share that and make graphs maybe lighter and keep a unrelated function separate, right? And this is the purpose of a provider to actually share your data. And as I said before, an application can't access the data of another application unless it's shared, of course. What is a DAO? It's actually a data access object. It's really an object we define. It's a simple abstraction of the SQLite queries, like instead of having a select from where query, you actually make a function where it's just a select function and you use pass the parameters like you have a select and you pass the function you want to read from a student table where there's an ID. So you create a method. This is just done so it's easier than remembering the class. It will make the code more readable, because the queries can get really big, especially if they are trying to query data from multiple tables. You'll have to do a join statement that is just cross-referencing the data, and that creates some really big statements, and you might not want to mess with those things, especially by hand. So you can use the data access object to create abstractions. These abstractions are really not very sophisticated like the content provider are, because it's just a function that is calling the query. So it's not very safe to like, it's not thread safe, and two queries may get called at the same time, and that's a problem to handle simultaneous queries, right? A provider might be actually better in this case if you're doing many queries, but a data access object is really simple and can actually be useful if your application is using only some data. You want to only store your own data. Making the provider might be just code instead of just having the simple queries. Like you can see the code on the repositories of the application and the exercise. A data access object is much simpler than a provider. Of course, it provides method instead of the queries, but the method just all the queries, so you don't have to get confused with those. And can be used when sharing data is not needed. Of course, that's the main advantage of the content provider. So this is a good alternative. If you're not wanting to share data with another application, you can just have this simple control to access your own database. So, files in Android. What can we say about files that we haven't said about files in Java? There's really not much difference, except maybe some use cases, but those also apply to Java. So I'll talk a bit quick about this files. It's the same as Java. it uses the Java interface and the Java methods of writing and reading files. So there is really not much to say about that. It uses output writer and input reader, stream writer, output stream readers, all that. So what are the uses of files? Well, when there's a database, we already have a solution to store our data and it's persistent, so we don't have to be worried about these things. Like the data gone missing or the data being deleted, it won't be missing or being deleted unless the application has an error or is deleted from the phone by the user or something like that. The app being killed will not harm our data, so there's no problem right there. The function of files is actually, well, files generated by the application, of course, because we could actually read files from an outside source, like if there's a formatted file, like maybe a JSON or an XML, and we actually add a code for a reader, like we saw in how to read assets. We actually could use that data for application, but generating a file is really a bit more complicated to find the news that we can't actually provide with databases or shared preferences. But some of those uses are logs, backups, and cache. Logs, of course, will log mostly errors, but this is something that may not even be needed because Android already provides an interface to provide the error logs when the app crashes. You probably have seen when an app crashes, there's a notify option. They'll actually send the data from the crash to the developer on the developer console. We'll say a bit about the developer console on the lesson 5, but now that is the place where you upload your apps and you can do some tracking about features, about uses, crashes, and stuff like that. Like maybe you can even see how much money your app is generating, how many users are still using it, how many have been uninstalled an application, and stuff like that. So Android already provides that as a way to track errors, automatically send the logs. Well, if the user actually decides to send the log, but the option is there. You could like write the error to a log using an exception handler. Like in Java, when you have an exception, you can actually handle the exception. In this case, you could use like write the exception to the log and save that to a file. The other thing is a backup. Like if we have a really big database and it has information that may be important for the user, you can actually write a backup to a file. Like we saw how to read files from an asset from a JSON. We could use the reverse process and actually write our information from the database to a JSON. So we could read the so we could export the JSON and maybe save it on another device. And then from the other device, we'll have the option to import the data. So we could have the data from the old device in the new one because we saved the file. Of course, this is handled much easier with an online database like Firebase. Again, we'll see that in the we cover Firebase and some of its uses in the professional developer course. But if you're interested, Firebase is a really great option for online database storage. And it's a good solution for this kind of applications. We could actually write the data to an online database and don't even need the backup. So what's the third use? A cache. We know about performance, and it's really important performance for Android apps. So using a file, we could actually cache some information, like maybe cache a really big bitmap, or maybe the user is interacting a lot with a particular document. We can actually cache that so the application runs faster. The cache is much faster than reading from the memory. We get a cache like getting a file from the device. You remember the get files directory command method. There's a similar method for this thing that is called get cache directory. And you get the location from the cache and you can write a file from there. Then you can just see if the cache has a file that you're interested, like a game might want to do this, like storing the background in the cache. Like if the background is used everywhere, imagine a whole level using the same background, you cache that information and then read it from there so the app runs better. And that's probably the best use for a file in Android, because there's really nothing we can't achieve with other methods. Of course, if you want to write to files, you're free to do so. Android is, and Java, of course, is really open on those ends. Like, there's no one right way to make an application. But, of course, heavy object, frequent objects, so they look faster, like SS games. So, the other thing, shared preferences. They are the final object, well, class used for data storage that we covered. And that's shared preference. It stores key value pairs like a hash map would. You just like store a preference like called maybe the volume, or maybe if you want to receive a notification, and you store the value like a number, a string, a boolean, and it persists. Of course, it's persistent storage, so of course it will not persist. But the problem with a shared preference is that it's not going to be able to store a complex object. Like it won't store an array, or it won't create a Java object that we create, like maybe a class, we create an event class or a student class that can be stored in a shared preference. It only accepts simple values. So the uses for shared preference. Of course, you might think immediately, what's the use for shared preference? Storing user preferences, right? Well, Android already did this. And there's already exists a class for storing user preferences, and it's just called preference. This class already implements the method to store, restore, and read the values from a preference. It already has its own layout and its own methods. It contains in some objects, like instead of having a checkbox, you create a checkbox preference, and the checkbox preference already saves its own state when it's changed, and you can query that state and do changes depending on the value. Like we already saw how to access shared preferences. You get a reference to the preference manager, then you get the value, and you can do something on that. You can also add listeners to the preference manager, like when the checkbox is being checked or unchecked, and we can work on that data depending on the state. Okay, for a shared preference, you store like simple objects and values, and and you may create your own screen, like you have the user settings like a username, or maybe the screen brightness, not if the user want to receive notifications or not, maybe the text size or the color, right? And they'll all be created, they'll be all using objects, and storing and saving, restoring their own values by hand. And the preference class has some objects. It is really not very expensive. Like it has a text, it has a checkbox, and a couple more classes, but it's not a really big class. It also has a list object, so you can store like many options and have the user select from that, like many colors for the application. But it's really not very expensive. One great thing about this is that you can actually create your own preference objects. You create a custom object, and the class handles the storing the values, and you can actually query those values really easily. Instead of actually handling the shared preference manager, it does it all on its own. So okay, the and of course, an important part is that this under the preference class it makes use of the shared preferences. So it will be redundant to actually use shared preferences because we have a preference class that already does what we're trying to do by storing the user preferences. So let's see how to create a simple preference activity. This preference activity, think of it as a normal activity. Like you can call it teaching intent, you can add elements to it, but these elements will be preference elements, not your regular elements like an edit text. Like I said before, you will, instead of using an edit text, you'll use an edit text preference. And this is how you create a preference activity. You create a preference activity by extending the preference activity class. And instead of like adding a layout, like we already are very familiar with the set content view method from the regular activities or also the fragments activity. You have to use the add preference from resources. And this preference object is like a menu. Think of a menu. You declare like it like a menu, but this one goes on the XML directory. It may not even be on the default project. You can just add it on the resources folder, right click, right click, add new resource folder, and add the XML folder. And in there, you add the preference layout. Well, the preference screen is called, where you have your preferences. And this screen is the one used for the activity instead of a normal layout. This code is quite simple and it may not even be right for today's standards because Android is really pushing fragments and they don't want to use activities. So right now the real way to implement this activity is actually using an activity and loading a preference fragment that is another class. But this works very well for the example. You create the XML preference, but what does it contain, right? It will look a little bit like this. You see the preference string at the top is, think of it as a layout, but it's using preference objects instead of regular objects. A preference category, it's a little header to the object, to the preference objects, like in a settings screen, you might want to separate from activity settings like the volume, the color, the brightness of the screen from user settings like maybe a username or receiving messages or something like that. You might want to separate that into different categories. And this is the purpose of the preference category. You just need to set the title for a category, and there's really not much there. It behaves like a, well, no, really, but think of it as a layout. You add objects inside it, and those objects will be inside that preference. You can see right there the deep text preference, and a little difference between objects and preference objects is that you actually use the key property instead of the ID property. Don't get confused about this, but key is the thing that we use to access the object instead of calling an ID. And title is like what will be displayed. I'll show how this looks in a little bit. So if you look a little bit below that, you'll see a checkbox preference, and it really doesn't look much different from a regular checkbox. But below that, you will see the custom object that I made for this example is just a number picker. Like think of a picker that you have a list and you want to limit the amount of objects that are being displayed on that list. You can actually there's not a preference for this. So we can create a simple example of how to handle this. And this is the custom object that I have created. To create a custom object, you extend the preference class. I just call this a number picker preference. And it extends a dialog preference object. That is because when we click on the preference, a dialog will open showing the object, right? So, what's different about this? Not much. You see, it's really similar to other classes and objects. Of course, we have the constructor, and we just call super on that. And the set dialog layout resource is like setting a layout or a dialog or a fragment. There's no difference right there. The onGet default value, I'll show how this is implemented in a bit. But basically, you keep a couple of variables that handle the default value and the stored value, and this method is the one that returns that value. The set initial value, maybe you want to declare a default value, like if you're setting a maximum list size for a particular screen, you might want to set that to maybe 3 or 4 or some value. You declare that right here. Well, that's on set initial value. On get default value is the opposite one that returns the default value. On bind dialog is what we want to do when the dialog actually appears. And on dialog close is what we do when the dialog is closed. Simple, right? This is the layout for the preference dialog. It just has the number picker. No, not really much to say about that. And let's see a little bit about the methods. You can see right there, I declare 3 variables. The default value, then I have the number picker, that is the number picker class, and the current value. The onset initial value is called when it's setting an initial value. So if we already have a saved value, we just set the already saved value. Otherwise, we have the default value. And the important part about persistent data and a preference class is the persistent string boolean. You have to call it to make sure that your values are being saved. Combine dialog. Here we just set some characteristics, default characteristics for the number picker, mean value, max value, and the current value. Then we call combine dialog view to actually create, well, the call to a super on dialog view. And on dialog close, if this reads like this, if the dialog was closed using the positive button. We get the value from the picker, we persist the value to the default value, and then we call the change listener. You'll see a bit about this in a few minutes. Okay. Um, Maybe we want to do something with this. Of course, they are preferences. We have to do something with them. We already saw how to actually access a shared reference and how to react to those things. But a preference activity, actually, you can get references to the objects using the key value, the key attribute that I mentioned when I was explaining the layout. And we can create a preference change listener. The, this, of course, acts as a listener that will tell you when a preference has been changed. Like maybe the checkbox is not checked anymore, so we can work on that. Or this, I'm just reading the values and setting that in a summary, so you can actually see that when you enter the activity. It'll look like this. This is the normal layout, I want to say, of a preference activity. We saw the three preferences, the username, the notifications, and the number of the list. Okay, so when we click on the current username, we are presented with a dialog. This was created on its own by the preference object. We don't have to do anything of this. And then when we click accept, we can see that our username is displayed on the summary of the object. This is how you should handle a preference screen or a settings screen, so the user can actually review its own preferences without having to going like to edit them or like getting them somewhere else. It's a really simple way and a compact way to show the user all its preferences. And of course, there's also the picker. And when you select a number, it will be displayed on the summary screen, or the summary field. So, your preferences may not have much use because we saw Android already made this. So, what should we use them for? Of course, you can still do that on your own, but there's a lot of existing code for that. So, you may not want to actually redo all that. It might be some waste of time. But you can use it to save in dynamic values, like values that might be being stored a lot or might change around time. Like think of a game, the sound, the music, maybe a display option like rendering, shadows, or graphic options. Those are really good ideas. Maybe you are using a particular option and you want to save it. It's a good idea to use as your preference. So we talked about a lot about saving data, the differences of the data persistent objects, how to use them correctly, some use cases, and we have an exercise for this lesson that actually handles the data as access object. So what can we do with the data access object? Remember, it's just a simple abstraction. It's no magic or anything underlying. So it's about the data. These exercises are very simple. But when working with data, we have to learn the pros and cons, and we have to select the correct option. We really shouldn't go using the first one or the one we know how to use the best, because that might not be the best solution. It might have some problems. down the road, and stuff like that is really easy to fall into. Like, I know how to use a database, so I will always use a database. It's not a good way of thinking. Content providers are not needed on applications that don't share the data. And this might be the best way to actually select whether you use a data access object or a content provider. If you don't need to share your data and you are handling all your inputs, outputs, and don't rely on like sending your data, you should use, well, you can still use the provider, but it's not really using its whole function. So it's kind of a, well, it's not the best implementation of a provider. For this kind of application, you can just throw raw queries and handle that on your own. You can still mix and match. There's really no saying that, oh, you just have to use a database. You can use all the different types of data structures to save your data. And you really should try and make that so that you use the right ones for your situation. There's really no wrong options when saving data, especially in Android, because really it really provides a lot of options. Sometimes, and of course I'm gonna go a little bit ahead into what the next course offers, but sometimes you don't want to use the local storage or may not be efficient. Like, think of the movie manager. If we think we might actually try to store that data on our phones, there will be really no point on that. So sometimes we have to use remote storage. We saw a sync adapter, but sync adapters can get really messy and really complicated really easily. You have to actually create a sync adapter, set the protocols, set the updates. Well, no, sync adapters can update on their own, but you have to actually create the web service and the database you're connecting to. It's really a lot of code. So, on this case, you might want to consider other options. There is Amazon offering an online database. There are really a lot of databases. But Firebase is really good because it provides already an abstraction of Android. Well, not abstraction. It provides an API. It already handles the connections, the disconnections, the persistence, and all these kind of things. The problem is that it's a NoSQL database, meaning the database stores its files on, well, files instead of tables, like the tables that we use in MySQL are not used in Firebase. Instead, they store everything in a JSON format. But it's already integrated with Android. And in fact, you can actually use Firebase right now if you use Android Studio because it already has the option to actually link to a Firebase project. You can use that together with local storage. Like, you can store your data locally. Maybe there's the user information that you're using a lot, or you're caching some images to avoid downloading them. Of course, some image libraries already do this for you, but you can actually store your data locally and remote. Really, there is no right way to use your data. But for this lesson in particular, and for this exercise, really the only thing that you really have to do is read how to actually use SQL queries, and that's really it. There's no really magic behind a data access object. You just have to understand how databases work. Um, that's basically it. I wanted to talk about picking a right solution of data, how to handle the preference changes, and a bit of Firebase. I got a bit carried into the next course, but it's really a good option. Um, that's all for the lesson. I don't think there are any questions. Okay, so we're nearing the end of the course. Really, we have only like 3 topics next week. Those topics, of course, are important because it's system integration and deployment, but is really this is practically it. So, of course, thanks again, and I'll be seeing you guys next week.